Today, we're diving into a tool that could completely change how we think about creating programming languages. We're going to go from seeing it as this mountain of a task to something you can manage from just one single file. Let's get into it. I mean, we use them every day, right? Python, JavaScript, C++, but have you ever just stopped and wondered, where do they come from? How are they actually built from the ground up? It's a pretty deep question. Because, it's not just about dreaming up some cool syntax. Traditionally, making a new language means you have to engineer this massive, sprawling ecosystem of different tools that all have to talk to each other perfectly. And this is that traditional toolchain. First, you need a lexer to chop up your code into little pieces like words. Then, a parser has to figure out if those words form valid sentences according to your language's grammar. After that, a semantic analyzer comes in to ask, okay, but do these sentences actually mean anything sensible? Then a code generator finally translates it all into something the computer understands. And you've got to have a build system to glue the whole thing together. It's a lot. So here's the big idea. What if you could just sidestep that entire mountain of complexity? What if you could just describe your language all in one place and have the rest just happen? And this is the answer. This is the philosophy behind a tool called ParseLang. It's simple, it's powerful, and it's a promise to do things differently. So here's the crucial thing to understand. ParseLang isn't a normal programming language. It's a meta-language. That means it's a language you use to describe other languages. You write one special file, a .parse file, and it literally generates a complete, ready-to-go compiler for you. This right here is the magic. Your entire language design, all of it, lives in a single file. And the compiler that ParseLang builds for you spits out a fast, native application with absolutely zero dependencies. No JVM, no Python runtime, nothing. Just pure standalone code. Okay, so what's actually in this magic file? Let's crack it open and take a look at the anatomy. The best way to think about it is as the master blueprint for your new compiler. So this blueprint has 4 main parts, all living together in that one file. You start with the lexer section, where you define the vocabulary, your keywords, your operators. Then comes the grammar, which sets the rules for how to put that vocabulary together. After that, the semantic section is where you add the actual logic and meaning. And finally, the emit section tells the compiler exactly what C++ code to generate. Now this is the aha moment. This slide shows how beautifully everything is connected. On the left, in the grammar section, you're defining a rule for a variable declaration. You're saying, this is what a variable looks like in my language. Then on the right, in the emit section, you have a matching rule that says, okay, whenever you see that variable declaration, here is the exact C++ code I want you to spit out. It's a direct one-to-one link from syntax to code generation. So elegant. All right, so how does ParseLang actually pull all this off? Well, it uses this really clever 2-phase pipeline to get from your description file all the way to a running program. Here's how the magic happens. In phase 1, ParseLang's own built-in compiler reads your .parse blueprint, and its output isn't code, it's a brand new compiler, built from scratch in memory, perfectly tailored to the language you just described. Then, phase 2 kicks in. This new compiler that was just born takes over, reads your source code, generates C++, and then uses a Zig and Clang toolchain to compile it all into the final native executable. It's a compiler that builds another compiler. It's just so cool. And let's not lose sight of the end game here. All of this sophisticated work gets you something incredibly simple, a fast native application that just works. It's all about getting that high-performance, dependency-free binary from a simple description. Okay. This is all incredibly powerful, for sure. But so what? Who is this actually for? Why does this matter in the real world? Let's talk about who really benefits from an approach like this. Well, if you're a language designer, it's a total game changer for speed. You can go from an idea to a working prototype in no time. If you're building a domain-specific language, a DSL, you can create one that compiles down to fast native code instead of being slowly interpreted. For compiler students, this is a goldmine. You get to see an entire working compiler in one single understandable file. And for tool builders, it's perfect for creating things like code generators or transpilers. This quote from the documentation really just nails it. The whole point of ParseLang is to handle all the tedious, complex, and repetitive parts of building a compiler for you. It lets you focus on the creative part, the fun part, the actual design of the language itself. And that kind of brings us to the big final question. When you remove that enormous barrier to entry, when you make it this easy to create a new language, what becomes possible? What would you build? A simple language for game scripting? A tool for data analysis? Something totally new that nobody's even thought of yet? If all you had to do was describe it, what would you create?